Hi, this is a quick little screencast to take a look at how to linearize the data for the golf tee and disc rolling apparatus lab. Um, you'll just need to open up Logger Pro and input your data. Hey, look at that. One thing that you want to make sure to do is label the columns here. So on the x-axis, I'm going to put time and include the units. And then on the vertical axis, I'm going to have position. So there's my graph. Another smart thing to do would be to title it. So this is position versus time. Oops. If you slap your name on there, sometimes that makes it a little bit easier to tell which one is yours when it comes off of the printer. And in looking at this graph, if I try to put a linear fit to this, you can see that some of the data points at the beginning and then the data point here at the end are above that line, and then the points in the middle appear to be below that line. And that's usually a tell if your points in the middle are on the opposite side of your best fit line from the points at either end. That's a little bit of a tell that you have a curved graph. And so I want to take a look at the process for addressing that. So in analyzing this, it appears that we're dealing with a top opening parabola. And what you'll have to do to turn this graph into a straight line is manipulate either of the variables here, position on the y-axis, time on the x-axis. In order to perform that manipulation, all you need to do is go up to Data and then New Calculated Column. Just in analyzing the trend here, I can see that position seems to be blowing up faster than time. Okay? What I'm meaning to say there is that these position values are increasing quite dramatically for slight increases in time. So to try to catch time up to that, I am going to attempt to square all those time values. So I'm going to call this new calculated column time squared. And since I'm squaring time, I'm also going to be squaring the units for time. So the unit here should be seconds squared now. In this box down here, it says to enter the equation. Maybe you're entering the function or whatever you want to call it. I'm not going to use an equal sign though, so I'm not sure I like that word equation there. Go into the variables, and here I can select either time or position. I've chosen time, and then shift 6 for the caret, and a 2 to square it. And sure enough, hey, look at that. Oh, it's the same graph still. What you'll need to do is go down here, and it's just kind of at the bottom of my screen, but if I click on time, my x-axis variable, I now have the option to select time squared. And if I do that, golly, that sure looks like a pretty straight line. And then by going into Analyze and Linear Fit, I'm able to get the slope for this line, the y-intercept, which that's times 10 to the negative 15, so that's pretty darn close to 0. And then also to try to determine the equation here now, it tells me, okay, the y-axis variable is position, m is the slope. It's just leaving this as x right now, so you'd have to go down to the bottom of your graph and see that your x variable is time squared. And then plus, well, that's 0 for all intents and purposes. So that's how you achieve a linearized graph using calculated columns. You have to consider what the shape of the graph is doing. So you saw there with the top opening parabola, by squaring the x-axis variable down here, I was able to linearize it. If I go back to the original graph, there you can kind of see the shape of it. One other thing too, if you were to try to print off this graph, this isn't the greatest because it has everything sort of chunked over here into 1/5 of the total graph space. If you go to Analyze and Auto Scale from 0, now it sort of maximizes the graph area. Now, just because the original graph wasn't linear doesn't mean that there isn't any value to be had here. You can see the trend regarding the slope. Here it starts off with a pretty shallow slope, but then as time goes on, if you were to try to fit a best fit curve to this, you can see how that curve seems to be getting steeper and steeper over time. And that curve informs us about velocity, because as we determined in one of the earlier units, velocity is the slope on the position versus time graph. So there's a tool here called the tangent tool under the Analyze menu that will allow you to go in and get values for a tangent line to the curve at those various points on the graph. So this is doing some heavy lifting math-wise for you. And I can identify that here at 1 second, the velocity is 9 meters per second. So that allows me to figure out the velocity at specific times. Now, in addition to figuring out the velocity at specific times, I can also figure out velocity at specific positions. And that can be accomplished by just going over to the y-axis. And just in looking at this, I can see it appears to be a little bit less than 50. And in fact, what you can do is take a glance down at the bottom left corner of the screen. You're going to have to pay attention over here where my mouse is right now. In the bottom left corner of the screen, you can see just a hint of it there, but it gives you the x and y coordinates for where my mouse is presently located. And it would appear that 22 meters per second is the velocity at 4 seconds. I could also consider 22 meters per second to be the velocity at position 48.2 meters. So that's another way that you can get a little bit more information off of the graph.